Let's see how we can use the simplex method to maximize the profit of the company Optimal Hummus by determining how much plain hummus and beetroot hummus they should sell at the upcoming festival. The mathematical model in standard form is given by the objective function which maximizes the profit, given that we do not use more time for mixing than is available. Here, S1 represents the amount of mixing time we have left after mixing x1 kilograms of plain hummus and x2 kilograms of beetroot hummus. In the same way, we cannot use more time for mashing than is available. Here, S2 represents the amount of mashing time we have left. Of course, all variables have to be non-negative. The boundary lines of the feasible region are given by the constraints of the mathematical model. Recall that the corner points of the feasible region are the basic feasible solutions of which one or more are optimal. For each of the four basic feasible solutions, two of the four variables are non-basic, which means that they are equal to 0. The first step of the simplex method is to find an initial basic feasible solution. In this example, we can easily find such an initial solution by selecting the original variables x1 and x2 as non-basic variables. This gives an initial basic feasible solution where both x1 and x2 are 0 and where both slack variables take the value of the right-hand side of the corresponding constraint. So S1 is equal to 240 and S2 is equal to 480. Because both x1 and x2 are 0, the objective function z has value 0. If we look at the objective function, we see that increasing x2 will give the highest increase in profit. So we let x2 increase while keeping x1 fixed to 0. This means that x2 will become basic and that either S1 or S2 will become non-basic. So we move along the x1 is equal to 0 line until we hit the next basic feasible solution. This basic feasible solution lies at the intersection of the lines x1 equal to 0 and S1 equal to 0, which means that x1 and S1 are the non-basic variables in this solution. This gives us the incumbent solution for which both x1 and S1 are equal to 0, x2 is equal to 60, and S2 is equal to 180, and which has an objective function value of 450. Moving the objective function line in a perpendicular direction will increase the value of the profit. We can do this by letting x1 become basic and moving along the S1 equal to 0 line. The next basic feasible solution we hit lies at the intersection point of S1 equal to 0 and S2 equal to 0. This means that S2 is a leaving basic variable and will become non-basic. This gives us an incumbent solution for which both S1 and S2 are equal to 0, x1 equal to 72, and x2 equal to 24, and that has an objective function value of 540. Moving to the next basic feasible solution will decrease the objective function value. This means that we have reached an optimal solution and the simplex method terminates. So using the simplex method, we have derived that company Optimal Hummus can earn a maximum profit of 540 euros by selling 72 kilograms of plain hummus and 24 kilograms of beetroot hummus.